Good morning. I'm Jongmook Lim from Spectraline Incorporated. We are located at the Purdue Research Park in West Lafayette, Indiana. Today, I would like to provide you with an overview of Spectraline products. We have three main product lines. The first one is a mid-infrared imaging spectrometer. The second one is a thermal line scan camera. The last one is visible imaging spectrometer. I will discuss each one of these in turn. The infrared imaging spectrometer is our flagship product. The spectrometer provides the spectrum from 1 to 5 microns. This spectra is obtained using an imaging array to provide simultaneous spectra across this broad range of spectrums. The 1 to 5 micron imaging spectrometer is the widest spectral range available in the market. The spectrometer also provides the spectra in approximately 800 microseconds. This is the fastest imaging spectrometer in this wavelength range. Finally, the spectrometer comes fully calibrated at our lab. Therefore, you can deploy the spectrometer with zero calibration downtime on your factory floor. The high speed and wide spectral range with out-of-box deployment capability make it cost-effective solution for monitoring mid-infrared spectra from various industrial processes. Here are some sample applications for the mid-infrared spectrometer. The first application shown here on the left is real-time monitoring of high-temperature furnace and combustors. This is an example of emission spectroscopy. For all types of furnaces, the spectrometer is used for monitoring the surface temperature of the products, such as molten metal or glass. In combustor, the spectrometer provides both gas and temperature and as well as their concentration. The second application that is shown in the middle is the monitoring of surface coatings. This is an example of reflection spectroscopy. An infrared source is used to illuminate the surface, and the reflected spectra is used to determine the various parameters such as moisture content in the tablet coatings. The last application shown on the right is the constituent estimation in the refining industry. This is an example of transmission spectroscopy. An infrared source is used at one end of a gas or liquid cell, and the spectra of the transmitted light is analyzed to determine the absolute concentration of the components. The second product that I want to highlight is the thermal line scan camera. The thermal line scan camera obtains a thermal line image at a blazing speed of 1320 frames per second. This is the fastest thermal line scan camera in the mid-infrared region. The camera can be used either emission mode or transmission mode. A wide range of lenses are available to image different object sizes at different various distances. Similar to the spectrometer, the thermal line scan camera is also fully calibrated in our lab and can be deployed very rapidly on your production floor. There are three principal types of application for thermal line scan camera. The first one on the left is the monitoring of plastic and thin material moving continuously over a system of rollers. For such an applications, the important parameters that are monitored are the thickness of the plastic web or coating and also uniformity of coating on the upright. Normally, the thermal line scan camera is used in a transmission mode, and the intensity of the radiation is used to determine either the material thickness or uniformity of coating on them. The second is in the middle is monitoring of high temperature ingot or billet. The thermal line scan camera is used in the emission mode to determine either temperature or emissivity or both in those applications. The final set application on the right is identifying coating defect on metal or other polished surface. The thermal line scan camera is used in the reflectance mode to determine uniformity of the coating. The last product in this slide is the ultra-fast visible spectrometer. Each spectra is obtained in 10 microseconds. Therefore, in 1 second, you can collect 100,000 full spectra from 0.3 to 1.1 microns. This covers the entire spectral range from ultraviolet to near-infrared. Like all other products, the visible spectrometer is suitable for production floor application and comes with a fully customized user interface for the most challenging applications. The ultra-fast spectrometer, as its name implies, is primarily used for studying very high-speed phenomena. Three sample applications are shown here. The first in left is the spectral characterization of explosions and muzzle flash. These characterizations are normally done in emission mode since there is a sufficient radiant energy coming out from the high-speed, high-temperature events. And the second in the middle is for characterization of rapidly tunable lasers. Some of the newer tunable lasers can shift wavelengths in excess of several kilohertz. Therefore, to study absorption of different materials with these lasers, a high-speed acquisition rate is required. The final application shown on the right is the monitoring of turbine blades. These turbine blades rotate at several thousand RPM. To obtain several measurement points on each turbine blade, a very high-speed spectrometer is necessary. For all our instruments, we have a wide range of accessories. For example, we have 1D or 2D scanners for hyperspectral imaging. With these scanners, you can obtain spectra over entire area instead of just at one spot. Sampling accessories include gas and liquid cells. A fiber input coupler enables connectivity of SMA terminated fibers. We also supply a complete mobile spectrometer platform with a battery for remote operations. We also supply laser pointers and various focus lenses to ensure proper targeting, and much more, including customized software for concentration and temperature estimation from the spectra. This is a partial list of our customers who have used our spectrometers. It includes a broad array of research institutes and commercial entities, highlighting versatility and ruggedness of our products.